Build Propulsion Lab live from Devoxx France 2024. We're coming to you from Paris, and I have here two guests with me for this episode, Julien and Josian. Welcome. Thank you for coming. And you have a very interesting topic that I didn't even understand what we are going to talk about, which is pretty rare, I have to tell you. I'm not that bad. So something that is called model mitosis.
Yes.
What's that? What does it mean?
So, in fact, it's about software architecture. You know that when we do microservices, it's really hard to find the boundaries of those services.
Oh, yeah.
Without building something which is called the distributed monolith, you know? And distributed monolith is something really painful to maintain, expensive to have, and so on. And the thing is...
Basically, distributed monolith is the worst of both worlds.
Absolutely.
It's the monolith with all the downsides of just being... I mean, we didn't decouple it, but we added all the complexity of being distributed.
Absolutely. And the thing is that the microservices were there to fix an issue we had with the monolith, is that we had two coupled things, but we lack heuristic to find those boundaries, right? And we discovered a pattern that we call the model mitosis, which help people to, in a progressive way, find the boundaries of the responsibilities by accepting that for maybe a long time, the boundaries can be blurry.
Yeah, and I guess people use all kind of stupid ways to limit the microservices. They're like, oh, it should be not more than such and such number of lines.
Yeah.
But it's pointless. Who cares how many lines are there? What is interesting is, does it have a single responsibility?
Yeah.
And if this service is encapsulated enough to work without the other services.
Absolutely.
And it's kind of the point also, the fact that we understood that microservices are here to help us decouple. So now the industry is rolling back, trying to decouple first into monoliths. But there's a lot of couplings that's pretty much invisible. It's what we call conceptual coupling, and that forces us to still release microservices at the same time, or still do modification on multiple microservices, even though we don't have like direct dependency most of the time. And our point is that sometimes we do see clearly what responsibility should be in which microservice, but it's still too early to split, because one of the responsibilities is too new to actually have all the hypotheses to know exactly how to make a new model out of this. So it's more, it's really trying iteratively to refine this new model, differentiate it from the previous one, and know at which point we are ready to release it into a different microservice, or just even completely cut it in a modular monolith.
So this is interesting. What you are saying is that we might not know what the boundaries are, and it's okay as long as we are ready to learn and adapt.
Absolutely. And we provide heuristics to detect when you need to have differentiated models for each responsibilities. And so that's the topic of model mitosis. Because, usually when we build software, we start with the MVP. Usually it's one responsibility, and you had a new one, which is kind of MMF, minimal marketable feature. There's not a lot of complexity, but you reuse a lot of things that was there already for another feature. If you try to split it like that, you will have way too coupling, between your services. So we call that, in fact, those heuristic is based on something we call model tension, is when you try to address several several problems with one solution, we give heuristic to know, okay, what should you do about that? And we try to split the model in place, meaning in the same service first. And if at the end you have a decoupled model, okay, you may go to different services.
It's kind of what we call the spork model. A spork is like half fork, half spoon, and it's useless for anything you might want from it, right? And these are the model tension we're looking for. It's when our model is starting to look like this, when it's starting to do multiple stuff that are orthogonal, and it cannot do multiple things efficiently.
And but you can only do it after observing a service in real time.
Absolutely.
Yeah, it's so we go with the flow, and actually that's the point. We go with the behavior, and we make it evolve iteratively. That's why it takes multiple months. You know, it's not just observing it in real time; it's playing with it. You know, we have to bring the new feature, see how we can update it, see what model tension. Before, I'd say we will feel the model tension, right? It's as you code with it, you can feel that something is wrong. Here we try to go a bit further and to actually give a theory and a few rules to detect it easily. But you do need to go and wait a bit for the service to be efficient. It's not an immediate process.
And what we try to do is to have first a good modular monolith, you know, and once we have differentiated model, okay, we can take the decision to go to microservices, because for us, monolith versus microservices is more a deployment strategy than a design one, because you have to take into account performance issues, I don't know, scalability and so on. But yeah, I mean, I think what is quite new in what we propose to the people is that you must accept that this is blurry. You may live with that. It's not a problem having a modular monolith. And those patterns that, according to the growing complexity, so it means that you have to go to production to see if your model is the good one.
Exactly. You can only learn by observing what is the behavior, for sure.
Yeah.
And is there like an automated tool that can help us detect those binaries?
I won't
Is
say
it even
so.
possible?
I don't think so, because that tool needs to understand the domain of your company. So does it exist? I don't know. Perhaps someday we may be able to train AI model on the business of the company, and perhaps, but even with that, I think it's quite hard to do. I don't know.
I think it's mostly because we stay on a conceptual level for the way we cut the model, and because we're also really interested in how we have these conceptual dependencies, you know. So it's pretty much impossible to detect directly from static analysis of what we have. But maybe with the rule we introduced, we could have something similar to a linter, you know, that can tell you, hey, you're doing something a bit wrong here, but it's still superficial.
Yeah, but at least those are kind of hints, right? Those are hunches. So hey, you might want to look here because there is something. Yep.
Yeah, but for example, it's when you have a concept that doesn't really have the same exact signification in both models, you can't really automate that. You know, you need to understand each of the model. You need to understand the domain knowledge, and at this point, I don't think we can really automate. Maybe with LLM or something, we could try some stuff. But at this point, it feels more like a hype than something actually doable.
Yeah, here you have an opinion on LLM as well. And yeah, folks, so here today we learned about model mitosis. Thank you very much, Julien. Thank you very much, Josian. It was a pleasure. And you all stay tuned for more episodes of the Build Propulsion Lab here at DevNexus 2024, right after this.